My name is Rabit Singh. I will review some problems from the engineering mechanics from the chapters properties of plane surfaces and the trusses. So, first problem is that you have given a parabola which is y equal to 4 minus x minus 2 square. What we have to find out is that what will be the centroid of the area between this parabola which is y equal to 4 minus x minus 2 square and the x axis. This is my x axis, this is my y axis. So, my aim is to find out the centroid of this area. For that, first I will find out at which point this parabola will cut the x axis. So, at the x axis y would be equal to 0. So, this will give 4 minus x minus 2 square equal to 0, which gives x equal to 0 comma 4. So, I have 2 points, first one is 0, second one is 4, at which this parabola is cutting the x axis. So, to find out the centroid of this area, by definition centroid XC is given by x dA over A, where dA is a very small area element. For example, I will take like a strip at distance x. So, if the width of this strip is dx and length is y, then dA is given by y into dx. So, before solving for XC, I will first find out the total area enclosed by this parabola and the x axis. So, for that I have to add up all this type of strips. So, for that I will just what will be the total area? Total area would be equal to limit 0 to 4 by dx, where y equal to 4 minus x minus 2 square into dx. So, this gives 0 to 4, 4 minus x square plus 4x dx. So, we get 0 to 4, 4x minus x square into dx. So, we have A equal to integration 0 to 4, 4x minus x square into dx. So, this gives 4x square by 2 minus x cube by 3 in limit 0 to 4. So, this gives 4 into 16 by 2 minus 64 by 3. So, this is equal to 64 by 2 minus 64 by 3, which is equal to 3 minus 2 into 64 by 6, which is 64 by 6, that is 32 by 3. So, we have found out that area enclosed by the parabola and the x axis is equal to 32 by 3. Now, we will solve for the XC. So, x is x into dA over A, which is 3 by 32 integration x by into dx, limit 0 to 4, because x is varying from 0 to 4. This is our by. This is dA. So, xc is given as 3 by 32 integration 0 to 4 x, and by is 4 minus x minus 2 square into dx. So, this is nothing but 3 by 32 integration 0 to 4 x into 4x minus x square into dx, right. So, this is 3 by 32 integration 0 to 4 4x square minus x cube by 3 x cube into dx. This is equal to 3 by 32. So, after integration we will get 4x cube by 3 minus x to the power 4 limit 0 to 4, right. So, this is equal to 3 by 32 4 times 64, right, by 3 minus 4 times 64 by 4, right. So, this would be equal to 3 by 32. So, this is nothing but 4 times 4 into 64 minus 3 times 4 into 64. So, this is 4 times 64 by 12. Is it okay? So, this will give 3 4 ja 12. This is nothing but equal to 2. So, xc is equal to 2. Now, we will find out what is the value of by c. For that, by definition, by c is given by integration by dA over A. So, A is 3 by 32 again, right, integration by into dA. So, what is this time? To find out by c, what we are doing, I am taking a small strip, that is dA. So, length of this strip is x. So, what is the length of this strip? So, for this strip, suppose this strip is at a distance by from the x axis, right. So, for a given by, you will have two values of x, that is x minus 2 square equal to 4 minus by, and x minus 2 equal to plus minus root 4 minus by. So, x equal to 2 plus minus root 4 minus by, right. So, here you have two values of x, that is x1 equal to 2 minus root 4 minus by, x2 equal to 2 plus root 4 minus by. So, what will be the length of this strip? This point is x1 and this point is x2. So, length will be given by, that is x equal to x2 minus x1, right. So, that is would be equal to 2 root 4 minus by, right. Now, what we need to do it, we have to add up all these strips to find out the value of by c. So, by c equal to 3/32 integration by dA, which is equal to 3/32. So, here what is y? Y is nothing. So, what is the area of this strip? Area is by dA is x times dy, right. So, x is what? X is 2 root 4 minus y. So, this is 3/32 into 2 integration by root 4 minus by into dy, right. So, what we have to do? We have to add up all these strips. So, minimum strip would be equal to 0 and maximum would be 0 to 4. So, we will integrate from 0 to 4. Is it okay? So, this is 3/16. So, we have to find out this integration 3/16 0 to 4 by root 4 minus by into dy. So, what is by c? By c equal to 3/16 integration 0 to. So, what we will do? We will integrate with respect to by, right. So, y is changing from 0 to what is the maximum point, because by is 4 minus x minus 2 square. So, maximum value of by would be when x equal to 2, right. When x equal to 2, then by equal to 4. This is the maximum value of by. So, this is just this point actually. This point, this is 4, right. So, we will integrate from 0 to 4 by root 4 minus by into dy, To find out this integration, let us by equal to 4 sin square theta, fine. So, dy would be equal to 8 sin theta cos theta d theta, fine. So, when y equal to 4, when y equal to 4, then what will be the value of theta? Theta would be equal to pi by 2, because sin square theta would be equal to 1. For y equal to 0, theta would be equal to 0. Okay. So, what is the by c? By c equal to 3/16 0 to 4 sin square theta root 4 minus 4 sin square theta into 8 sin theta cos theta d theta, right. So, this is equal to 3/16 integration 0 to 4 sin square theta right. 4 minus 4 sin square theta will give 2 cos theta, right. This is 2 cos. So, I have to limit is because I have changed in the variable theta. So, limit is 0 to pi by 2. So, this would be equal to 8 sin theta cos theta d theta, right. So, this is equal to 3 by 16, 0 to pi by 2, 16 into 64. So, this is 64, 8 times 2 times 4, 64, right. So, this is sin cube theta, 8 sin theta cos theta, this is fine, 4 sin square. So, sin cube theta cos square theta into d theta, right. So, this is the entry. So, 16 times 64, 16 times 4 equal to 64. So, this is 12, 0 to pi by 2 sin cube theta cos square theta d theta, which is 12, 0 to pi by 2 sin cube theta cos square theta d theta. Okay. So, to integrate this, what we will do, we will write this in this way, 0 to pi by 2 sin square theta. I will write like 1 minus cos square theta into cos square theta. So, one remaining sin theta will be here, sin theta d theta. So, this is 12, 0 to pi by 2 cos square theta minus cos to the power 4 theta sin theta d theta, right. Is it okay? So, this would be equal to 12 minus cos cube theta by 3 plus cos to the power 5 theta by 5, 0 to pi by 2. What I have done? I have taken just cos theta equal to x. So, minus sin theta d theta equal to dx. So, this would be equal to 12. So, for theta equal to pi by 2, this would be equal to 0. So, only limit we will think about theta equal to 0. First one would be 1 by 3, second one would be 1 by 5. Is it okay? So, this would be equal to 12 into 5 minus 3 over 15, right. So, this would be 12 times 2 by 15. So, 3 2 is 4, 3 4 is 12, 3 5 is 15. This would be equal to 8 over 5. This is our YC. So, the centroid of the area is XC equal to 2 and YC equal to 8 over 5. Okay. Our next problem is a beam is loaded by a load, that is a triangular loading actually. So, here load is 0 and here load is 2000 Newton meter inverse. So, the problem is we have to find out the force applied by the supports, that is A and B. So, for this first we will calculate what is the total load of this system. So, total load would be equal to integration x1 to x2 fx dx. In this case fx is this line and x1 is this point, minimum of x1, x2 is this point. So, integration is nothing but the area of this triangle, which is A, B and C. So, area of and this is 2000 Newton. The base of this triangle is 2000 Newton per meter. Length of the beam is 3 meter. So, our area is x2 minus x1 times 2000 by 2, which is 3 into 2000 over 2, which is equal to 3000. This is my total load, right. Now, we have to find out the point at which this total load will work. That point is given by the centroid of this area, right. So, we have found that the total load of this system is 3000. Now, the XC for this triangular loading is given by 1 by 3 x1 plus 2 x2. So, in this case x1 is equal to 0 and x2 is 3. So, this is nothing but 2 meter. So, our load will act at x equal to 2 meter from the support A. So, if the load is acting at 0.2 meter, let me make a diagram for this. So, these are our supports, this is load which is at 2 meter away, this is R, this is A, this is B, this is my normal reaction N1, this is N2, right. So, our whole load will work at the centroid, which is at x equal to 2 meter, right. So, to find out what are the forces applied by the supports, these forces are N1 and N2. So, for that let us take torque at point A, right. So, at point A the torque due to N2 would be equal to N2 times 3, right, and torque due to the load would be equal to R times 2. So, N2 would be equal to R, which is 3000 into 2 by 3, which is equal to 2000, right, because total N1 plus N2 should be equal to R, right. So, then N1 would be equal to R minus N2, which is 3000 minus 2000, which is 1000. So, the force on the support support A, that is N1, force on support A, which is N1, N1 would be equal to 1000, and the force exerted by the support B which is equal to N2, that is 2000. So, our next problem is about the application of transfer theorem. Application of transfer theorem. Transfer theorem. So, what is the transfer theorem? Transfer theorem says that if we have given a set of axes which is x, y, right, and we want to find out the moment of this area with respect to this set of axes which is x, y. So, transfer theorem says that if we have another set of axes which is x prime, y prime, and these axes are going from the centroid of this area. This is our area. So, this point is the centroid of this area. So, transfer theorem says that Ixx, that is the moment of this area with respect to xy axis. So, this is equal to Ix x prime plus y naught square into a, right, where this Ix prime xx prime is the moment of this area with respect to these axes x prime, y prime. So, to what we will do, we will take an example to understand this transfer theorem. So, for that let us consider a circular area of radius a. So, this is just a, and the centroid of this circle of course will be at the center of the circle with respect to these axes x prime, y prime, fine. So, if the distance of the center of the circle from this point, this is O and this is O prime, is x naught and this is y naught, right. So, the moment of this circular area with respect to x by axis will be given by Ixx prime plus y naught square into a, and what is the value of a? That is pi a square, right. So, only thing we have to find out is the Ixx prime, x prime, x prime. So, what is the Ix prime x prime? This we can find out in this way. Suppose we have a circle, right, this is x prime, y prime. We want to find out the moment of this circular area with respect to x prime, y prime axis. So, to find out this moment, we will take a strip at a distance by and by symmetry we can see we can at this same, because what is the Ixx prime? Ixx prime is given by y square into dA. So, if we consider this strip, so this strip will be given by x times dy, right. Similar strip you will find another side which would be x times dy at a distance minus y, right. So, that is a similar strip. So, what we want to do? We want to do this integral by square dA. So, for that, because we see the circle, the equation of the circle is given by x square y square equal to a square. So, y square would be equal to a square minus x square, right. So, y equal to plus minus root a square minus x square. So, for a given value of x, we have two values of y, which is plus y and minus y. So, to find out this integration, we have y square, what is the dA? dA is x dy, right. dA is what is, this is our x distance, x dy. So, from this formula, what is the x? X equal to actually plus minus root a square minus y square, right. So, if we want to find out the length of this strip, that would be equal to 2x. Okay. So, let me make a clear picture. This is x prime, this is y prime, and this is x1, this is x2. So, from the equation of circle, we find out x equal to plus minus root a square minus y square. So, x1 is minus root a square minus y square, this one. x2 is root a square minus y square. So, the length of this strip would be equal to, we suppose if I write that by x, so length of the strip would be equal to root 2 times a square minus y square into dy, right. But we are considering two strips. What I will do, because I have to integrate. So, what I will do, I will integrate from 0 to a, and because there is a similar integration in another side. So, I will just make it 2 times. So, this is 2 times y square 2 root a square minus y square dy integration from 0 to a. Okay. So, this integration would be equal to 4 times 0 to a y square root a square minus y square dy. Okay. So, what is the I x prime? X prime would be equal to 4 times integration 0 to a y square root a square minus y square dy. Let y equal to a sin theta. So, dy would be equal to a cos theta d theta. So, this will give I x prime would be equal to 4 0 to a y square, which is a square sin square theta, a square minus y square, which is a square minus a square sin square theta, dy is a cos theta d theta. So, this will be equal to 0 to a would be 4 times sin square theta, and this will be cos theta d theta, right. So, let us see what will be the limit if we change variable from by to sin theta. So, when by equal to a, sin theta would be equal to 1. So, theta would be equal to pi by 2, right. When by equal to 0, theta would be equal to 0. So, this limit will go from 0 to pi by 2. So, this is nothing but 4 a to the power 4 0 to pi by 2 sin square theta cos square theta d theta. So, this will be 4 a to the power 4 integration 0 to pi by 2. So, we can write this integration, let me write it directly. So, this integration comes out to be, because cos 2 theta equal to 1 minus 2 sin square theta. So, in that way we can write 1 minus cos 2 theta over 2, and this would be 1 plus cos 2 theta over 2 d theta. So, this would be 4 a to the power 4 0 to pi by 2 1 by 2 का whole square minus cos square 2 theta by 4 into d theta. So, this would be 4 a to the power 4 0 to pi by 2 1 by 2 का square minus cos square 2 theta by 4, right, into d theta. So, this will be 4 a to the power 4 1 by 4. So, this is limit, after integration I will get this 1 by 4 into theta, 1 by 4 into, let me write it again, 1 by 4 0 to pi by 2 limit minus integration 0 to pi by 2 cos square 2 theta by 4 d theta. So, this will be equal to 4 a to the power over, so this should be 4, right, 4. So, this is equal to pi by 2, this is, so this gives pi by 8 minus integration cos square 2 theta, cos square 2 theta we can write as 1 plus cos 4 theta by 2 into d theta. So, this is nothing but equal to 4 a to the power 4 pi by 8 minus 1 by 4 into pi by 4, because integration on cos theta will give 0. So, this would be equal to 4 a to the power 4 pi by 8 minus pi by 16. So, this is nothing but 4 a to the power 4 into pi by 16. So, which is pi a to the power 4 by 4. So, we have found out I x prime. So, the moment about the x axis of the circular path of radius a will be equal to I x prime plus by naught square into a. So, this is nothing but equal to pi a to the power 4 by 4 plus by naught square into a is nothing but pi a square. So, this is pi a square, pi a square. Okay. So, we have done the 3 problems from the chapter properties of plane surfaces. Thank you very much.